take text, be it English, Chinese, Japanese, or whatever, and you train an LLM on it, it doesn't have any concept of rhyming, and especially not in the sense of tonal rhyming like Mandarin languages, Cantonese, Taiwanese, Mandarin, Vietnamese, languages that where the tone matters. That information is lost when you feed it to LLM. So obviously, it was never going to be able to actually rhyme in Mandarin because it never learned that.
Welcome to Practical AI, everybody. My name is Jeff. I'm here with Peter Lynn. Practical AI is brought to you by Pocket AI. Pocket AI is a tool you can use to edit the weights of your model. With Pocket AI, you can prune over 60% of the weights in your model while increasing accuracy. Peter, we wanted to hit up another Wes Roth video today. He was diving into Alpha Evolve. Tell us a little bit about Alpha Evolve and what Google has kind of been working on.
Yeah, so this is actually not new. It's been around for a number of years. So the one of the goals of machine learning since pretty much the beginning was have a machine train itself, right? So in other words, it could evolve on its own. But up until recently, it was pretty hard because if you want to train a model to do a certain task, how do you evaluate it? How do you prove that what it did was correct? And for most of the history of AI, humans have been the evaluator to prove like, okay, did it get the right result or did it do the right thing? If it's a robot, if I said, get me a cup of water in the blue mug, and it came back with a pitcher of water, well, that's not a glass of water, that's a pitcher, right? And so that's been the hard part is how do you build a generic engine to evaluate things? And so people have been working on this for many years. And so now Google has shown that they've been able to do it with circuits and math. And so some very narrow domains of like they can build an engine to evaluate the results. And then that enables it to actually then self-train and evolve.
Okay, so this is depending on the context and the understanding of each scenario, this is fairly easy to understand. You're training a model and you want it to be able to train itself. And so therefore it needs to be able to do something specific. And that specific thing is it needs to be able to evaluate.
Yep.
Okay, so then the question immediately goes to, well, what's the human doing? Like, where's the human involved in this whole thing? And did we just cut out the human? What's happening there from a human perspective, and are humans still baked into this process somehow?
So right now humans are still needed because we need to create the initial data set. We need to create the initial programs and tools and models. And then we hook it all together and then tell that go learn this thing and get better at it, right? And so for the last I would say 5 to 10 years, we've had Siri, we've had Cortana, we've had Alexa, but none of them are at the point where it's 100%. And so everyone that signs up for these services has to like opt in or opt out of let a human listen to my voice recording and figure out like where did Alexa get it wrong or where did Siri get it wrong, right? Because the evaluation part is actually very tricky for things that are not math.
Mm. Okay, well, let me share then from the Wes Roth video. So, what you're saying is that two things that I just heard. One is you've got the scientist, engineer slash human involved in all of this stuff.
Yeah.
Um, but because one of the things that they were able to sort of hook up to this series of machines was some ability to evaluate,
Yeah.
and then but that was confined to something that's kind of either a one or a zero or a correct answer or not. It's something like math. So could you do this for like training LLMs, for example, if it's you want to get make this poem into a Shakespeare sonnet or something like that.
So that's much harder. Like, so for example, this week I was playing around with translation on Claude and GPT. So I had a poem that was in English, and I told it translate this to Mandarin and make sure it rhymes. And so I did it like a dozen times, and none of the translations rhymed at all. Right? And so there's a clear reason why that happened. It's because when you take text, be it English, Chinese, Japanese, or whatever, and you train an LLM on it, it doesn't have any concept of rhyming, and especially not in the sense of tonal rhyming like Mandarin languages, Cantonese, Taiwanese, Mandarin, Vietnamese, languages that where the tone matters. That information is lost when you feed it to LLM. So obviously, it was never going to be able to actually rhyme in Mandarin because it never learned that. So then I thought,
Right.
okay, how do I take advantage of this, or can I prompt engineer it so it actually kind of sort of rhymes? So I spent about 45 minutes to an hour where I kept prompt engineering it, and finally I said, okay, let me give an example of a Chinese poem, and then translate this English poem into Chinese following the same kind of similar structure. So then it finally started to actually rhyme. And it took like about 5 to 6 attempts before I actually generated a poem that actually would rhyme. It wasn't great, but it actually rhymed.
Okay. So you said it's harder to do the something like that. Is it possible though, you think?
Well, so again, right now there are no great tools for doing fuzzy evaluation because it's not a 0 or 1. It's degrees of correctness or
Hmm.
degrees of closeness.
And you're saying that in order to get a machine, an AI or a machine to be able to evaluate that
Yeah.
and then give an opinion on the shade of gray that it chose,
Yep.
it's a tall order to do that.
Yeah. Yep. It's it,
Okay.
it's it's just not easy because it requires you know like for example when you write a poem, if you tell GPT write a poem, it will rhyme based on what it understands of English. But most of the poems I've asked it to generate, they just rhyme, but it has no real substance. It has no real context. There's no real story. It's just like, oh, I've consumed all the poems on the internet in the whole entire world, and these are things that kind of rhyme. So I'm just gonna put it together.
Well, one of the things that we talked about 2 weeks ago, RLHF, was the human starts doing their thing,
Yeah.
and all of a sudden the model starts to get really smart in one area, but then catastrophically forgets a bunch of other stuff.
Yep.
Do you think that if we were able to set up the evaluation loop and self-train
Hmm.
using AIs, would it run into the same problem of catastrophic forgetting?
It would help reduce that effect, but there still is a risk because of the fundamental architecture of neural networks today. Yeah.
So basically, the transformers attention is all you need. That could be there could be a limit there, or a limitation anyway, in terms
Well, the
of
limit
forgetting.
is understanding what the weights are doing. Until we can understand what the weights are doing, I think that's going to be a bottleneck.
Okay. All right. So back at this breakthrough. Was it a breakthrough? Was this or maybe it's obviously a breakthrough, but was it a ceiling that they busted through with this?
No, I think this is the beginning of people getting better at writing engines to evaluate. So I think in the next couple of years, we'll see this tech improve to where it'll work better and better and better. And then it'll, I suspect that it'll get really good at doing kind of evaluating programs. Like if you ask it, write me a program in Python, it's going to get much better in the next year.
Is this the pathway to superintelligence, or is it a key a stepping stone to
I
that?
think it's an important tool to get there, but it's not the key thing.
Okay. understanding the weights is the key thing, it sounds like.
Yeah.
Great, Peter. Thanks for the explanation on this one. Very interesting video. We'll include it in the comment box, and we'll look for any questions you have. You can follow us on Spotify. We are there. Always remember to listen to us on double speed, since Peter and I talk slowly. We will catch you next time with a new topic. Thanks, everybody.